Hello, everyone. Welcome to Introduction to Computer Science, week number 3, and this is the lecture video for this week. I am sharing with you Blackboard for week number 3, which is opened up for you now. So I'll go over the material posted on the Blackboard, and then I'll go over the lesson plan and take care of the items that you need to do. So here's the usual objectives. We are going to really get moving in terms of understanding the material for Python and related items this week. So this will be a heavy week. Some of the statements for the Python, how to write a program, some binary numbers, and all that stuff will be happening this week. For the instructional material, there is a lesson plan posted up for you. Here is the lecture video from last term, which should be pretty much the same. I left it on there because if you want to take a look at them, but as soon as I post up a new lecture video, I will replace with it. I think some of the dates that are shown on here is just from last term. And here is the binary worksheet that I'll refer to later on in the lesson plan. In terms of the Zybook, we will be working on chapter 4 and 5, which deals with branching and loop, and there will be a chapter 3 from the textbook. Okay. So the rest of items here are the list of the assignments. Here is a textbook question assignment based on chapter 3. I'm asking you to do 2 items here. Write your first name in ASCII code. I'll show you how to do a sample, and then do a binary worksheet, question number 1 through 6, which is posted right here, but I'll also copy and paste on to your lesson plan. Here is the Zybook interface that I'm asking you to do for chapter 4 and chapter 5. So if you click on one of these guys, it'll take a minute to link, but it'll take you into the Zybook assigned portions. Okay, so don't go directly into Zybook. Just make sure that you click here to get to the Zybook for chapter 4 and chapter 5. Not everything in chapter 4 and 5 are assigned. I only assigned portions out of that, so you're always welcome to go directly into Zybook to just look around and take advantage of whatever is out there for you. We are going to do a programming lab this week, so here's a great calculator that I'm assigning for you to create. And so I'll do a little bit of demo. I may do part of it, and then you can just finish it off. Or if you want to, you can just do it from scratch. But anyway, here I'll come back and talk a little bit more about this. Okay. So if you click on the, let me pause here for a sec. So if you click on the lesson plan here, you should get, let me minimize this guy here and bring the lesson plan here. So that you should see this one right here. And let me make it a little bit bigger so you can see easier. There's a lot of stuff on this lesson plan, but it's not really that long. It's only from here from here. The rest of them is some miscellaneous notes that I may use to explain things. So if they're helpful for you, keep it. If not, then you can just toss it out. But let me go through the lesson plan with you and take care of some stuff. So I talked a little bit about this. I think I think everybody is making an active contribution in this class by turning in the assignments. A little bit of the Zybook assignments, it's lagging, but make sure that you are making progress in that. And if there's any question, feel free to email me and ask me. All right, I'll be happy to respond. Here's one a tip that resource that might be useful for you. So this is a program is. So if you click on them, it's one of the online tools that you can use to learn more about the Python programming. So I thought that was a little useful, so just wanted to share. Feel free to use it. If not, then no worries. Goals for this week is to take care of the chapter 3 from the textbook and do the assignments from Zybook, as well as the programming lab. So maybe I should put it in here. So create a program. So maybe I'll update this, a minor update. But anyway, in terms of the assignment from the textbook questions, there are two. The first one is to do the binary worksheet 1 through 6 in the attached. Let's see right here. So that's this guy right here, right? So not that one, this one right here. So if you click on them, this is what you get. But I copied a portion of this already onto the lesson plan, so you can just look at it. I already did the first two, so you only need to do the other two. But make sure you make sure you do these two so that you understand what you're doing. And even though I kind of worked it out for you, I just want you to still do it. So do it for all 6 of them, and then you can turn it in. But the way that this works is I just made a copy here. So I will work it through these two guys, and you can do something like this. All right. Of course, you can always go to the binary calculator online. So let me pull that up to check your answer. Let me pause it here real quick. So maybe even before or after, doesn't really matter. But let's say you were doing this right here, and you wanted to check the answer to this and see if this is correct, right? Because you did it and you want to just verify. So you can go to, there's a whole bunch of binary calculators you can find online. And here, it's really easy, straightforward. It's a binary, just calculator.net. Maybe I'll put this on the lesson plan here for you. So update that. But anyway, so let's say you want to do this guy here. All you got to do is just type it in. So type in 11110. It'll be a plus. You can do other operations here. And then you can put the other one, this guy right here, 0001, right? So if you calculate, it gives you the answer. And the one nice thing about this guy here is it gives you both binary value answer and the decimal answer. So you can kind of have an idea what that's like without even having to convert, right? But anyway, so as you can see, here you have I'll be counting from the right. It'll be 1, 1, 1, 1. There's 4 ones here. 1, 2, 3, 4, right? And then there's a 0, 1, 0, 1. It's giving you a leading 0, partly because there is a select here is 1, 2, 3, 4, right? 4. I'm not sure exactly why they give you a 0. Sometimes they give you 0 to make it a 4 digits. But anyway, so the leading 0 doesn't really matter. So that's how you do it. And you can do the same thing for the other guy. So let's just do this one real quick and see how we're supposed to do this. Adding is really straightforward. You basically just add, the way we typically add by adding the columns. And you want to start adding from the right. And then if there is a carryover, then you can just push it over to the left, right? So 0, 1 is you add 0 to 1, you get a 1. 1 to 0, you get a 1. They're all the same. The only challenge maybe is over here. If you add 1 and 1, you get a 2, right, in decimal. But there is no 2 in binary. So uh, 2 in binary is 1, 0, or uh, it has to recycle, and this becomes a 0 with a carry of 1. And so that's why you put a 1, 0 here. So that's how you do that one. Subtraction, you do it the same way. You start from the right, and then you kind of do it the similar way as you would do the subtraction in a decimal number. We won't really worry about if the number on the bottom is larger than the top. If this is a larger number, it will become a negative number, right? Which is possible, but we won't really worry about that too much right now. Although there is what's called a two's complement. And as a side note, there is no real subtraction in electronic level. Everything is a addition. We don't take away things. We can only add things in electronic circuits that are adding that are when you have two numbers. And numbers don't really exist. I mean, they exist as a binary ones and zeros, right? And these ones and zeros are not really numbers, but they're voltages. So we'll talk a whole lot more about that as coming down to the pipe. But anyway, just getting back to this subtraction. So you start from the right here. You can't really take away 1 from 0, so you have to borrow. You want to borrow from here, but there's nothing there, so you go over here. You keep on going till you get something, right? So this one, there is one, so you want to borrow it here, which is a 2. But the reason why you borrowed it is not because of this guy, but all the way here. So you leave 1 here, and then the other one goes over here as a 2, and then the other one is you leave 1 here, and then the other one goes over here, which is a 2, right? And then 2 minus 1 gives you 1, and then this 1 minus 1, 1 minus 0 is a 1, 1 minus 0 is a 1. Here, because you lent it out, it becomes a 0, 0 minus 0 is a 1, and then here 1 minus 1 is a 0. So the answer would be 1, 1, 1, or just with a leading 0 of 0, 0. So you can put that down, and you can show me some of these if you do it by hand, and you do it similarly for the other 4 guys, okay? So hopefully that works out for you. And then here's another item that you need to do for this assignment, and that is to write your first name in ASCII code. So basically all you got to do is to go to the ASCII table. So let me get over there and bring this guy over here. So maybe you can see the whole thing here. So let's say your first name is Bob. I kind of chose it, something short. So you have a capital B, lowercase o, and a lowercase b. So all you have to do is to just look at the find the capital B here. So let's see here. Let's see. So here's a B, right? So here's a character, and these are different number systems. Capital B is right here, so you can write number 42 in hex. You can write in other number systems, but typically we just say 42 for the hex. So that's that. And then small o, I think it's down here somewhere, so it'll be 6F, right? So you write 6F. And a small b right here is this guy, 62. And so the answer is 42 6F 62. So that's what you write down, okay? So that's all you got to do. If your first name is really long, make it kind of short. And as long as you know what's going on, that should be all fine, okay? So, so here's the assignment for chapter 4 in the Zai book. So let me pause it for a second. So I want to do a quick demo on the Zai book chapter 4 and 5. I'm not actually going to click on these things because I'm not actually doing the assignments because it gives you just a sequential sections that are being assigned. So for the purpose of demo, I'm going to log directly into the iBook myself as a instructor. That way I can see all of the items. And also I'm going to post up exactly what is assigned in terms of the iBook assignments. I pasted up here in my instructor view. Here is the chapter week three, chapter 4 and 5, and then I can see what I've assigned in terms of the sections, right? So here it doesn't tell you exactly what is assigned. I will update that if I don't remember. Otherwise, as you can see, I copied and pasted up here in the lesson plan, so at least you will know it from by looking at this. And then I'll also update the lesson plan after the video is recorded. So I'm going to put this on the side a little bit, and then I'm going to come over here, and I'm going to, let's say, look at chapter 4. As you can see, chapter 4 is a branching and talks about sort of a very basic concept of decision-making options that you have with the other, majority of the programming languages. So here's a if-else branches that it's going to talk about, and then there are a few other options that you can have. And then, so let me kind of, so it may be worth a while for you to actually, look at all this in terms of the concept. But in terms of the, so you have this kind of a language here. If x is equal to this, do that. If not, then check another condition. If x is equal to this, and do that, right? And if it is not this and not that, and check one more condition, then do this, right? If this is satisfied. If none of these are the case, then just one else without the condition, then do this. So it'll catch all possibilities in terms of the value of what x is. Okay, so that's what we're going to be using. Let me kind of go back to, there's some equality and relational operators available in Python programming languages, so you can check for if they're the same. Notice that here we use a two equal sign to see if they are equal or not, right? So when you use only one, that means that they're being assigned from the right to the left, but we use these two guys. So this is a condition that you want to check if they're equal. If they're not equal, you have a few other relational operators. If there's less than or equal to, or less than or equal to at the same time. So you have some of these operators available for you. Okay. It's also important for you to know the order of operations. So it gives you what gets evaluated first. And so make sure that you pay attention to the order in which they're going to do this, right? So go through the exercises and make sure you kind of understand. But there's nothing special or unique that Python is using. It's pretty much standard. So that's a little bit about the branching. In terms of the loop, let me pause here for a little quick. So as you can see from the chapter 5 or section 5 here in the iBooks, there are several standard ways that programming language allows you to repeat things. So this one we'll talk about some general concepts. There is what's called a while loop. So and then there is a for loop, and then you also have a nested loop, right? So and then there's a way that you can use counting to kind of specify exactly how you want it done. But the general concept here is for you to repeat things. There are needs to do this. So like if you're adding some numbers or whatever, right? So and then for the while loop, has a structure or syntax. So while is they reserve the word, and then you provide an expression, right? So while some expression is true, and then if you put your operations or a, commands here, it'll do all this. So the only way that any one of these is going to be executed is if that expression that you're checking is true. If that expression turns out to be false, then none of them will be executed. Like for example here, here you're assigning the value of 2 to the current user and a value of y to, let me see if I can make it a little bit bigger. Maybe here. So value of y to the user character, and here is saying while the user character is y, in this case, if what this is true, do all this, right? Of course, this will be the current character has a value of y, and it'll be the same only because you assigned it, right? But what if you didn't know, right? What if a user puts it in, right? Instead of assigning programmatically, if this was received by a input by the user's keyboard, then you don't know what it is. And so if you're checking to see, and the use for that would be like if your user puts in the password and your stored password you already know, and you want to check if that password is the same as what the user put it in. And if that condition is true, then let the person in and then do whatever needs to be done, right? But anyway, so while this condition is true, all these things will happen. If the user, if this is false, let's say you assign the value of x, none of these will happen, and then it'll just jump out to whatever the next statement is. Notice that they are indented here. The indentation matters in Python. So print done. I don't know what that done really means. Maybe it should say finished with a while loop or something like that. And notice they're in quotation marks. So while is a good repetition a mechanism. Here you're asking the user to put in a value. It might be nice to ask or inform the user what value to put in. Choices of whatever. If it keeps remaining as a y, it'll just go on forever, right? So and anyway, so there's some issues that you want to be careful about using the while loops, but this is the basic concept. Here's another example that you can kind of look through there. Counting. Let's see. So you can count something like this here. I is equal to I plus 1. Remember that in a statement like this, we do the right side first and assign it. So this is the way you increment the value of I. So whatever I was, if it was 1, 1 plus 1 will be 2. Value of 2 is assigned to the I now, right? And then it goes back up here, and then it checks this condition, and if it's true, it'll do whatever it's doing. So there is a count that you can use to control the while loop. Okay. Here's a for loop that some of you may be more familiar with. And so the way this guy works is, let's see if there's a good example here. So here, let's see if there's a, yeah, so maybe this is okay. So the for loop has a syntax of the reserved word for, and then as you want to give it a variable and some sort of a condition, right? So for this to be in some condition, do all this, right? So like here, for C, a variable C is in the channels, and you provide a list of items here. As long as this is in here, do this, right? So you can do that. Here's a for character, whatever the character is in here, take me to here. You want it to increase or add to it, and then print it, right? And so here's another one example. You can increment here a value. So you can use the for loop to control exactly when it starts and then when it ends. Okay, so one difference between for loop and a while loop, let me see if I can go back here, is that for the while loop, it checks the condition before it actually does things. For the for loop, it'll do it right away. So if you don't want things to be repeated, not even once, then you may want to choose the while loop instead of the for loop. Okay, and that's what this for while loop versus for loop is about. And then, of course, you can have a nested loop, as is typically the case in other languages. So you can have a nested loop here. You don't have to only use a while within the while. You can mix and match. But if you want to have a nested loop, that's what you do. And the way it happens is it'll just execute from top to bottom. It'll do this here, and when it comes here, it'll do all this, then go back up. So it'll kind of like the seconds and the minutes and the hours, right? The seconds repeat the most frequently, and then when it's all done, it updates the minutes, and then it'll do all that along with the seconds, and then it'll update the hour and stuff like that. So nested loop would be a very powerful mechanism they can use. Let's see. Take a look at the break and continue. If you want to exit the looping mechanism, we can use that. I think that's pretty much it from the Zybook. Let me bring in some notes from the lesson plan here. I'll come back and talk about the one's complement, two's complement. There's some notes about the chapter 4 and 5 from the Zybook that I copied and pasted, and so look at that if it's helpful for you. Let me talk a little bit about the number system here that I put it on, just to kind of be comprehensive and cover this. As I mentioned a little bit as a side note, when I was doing additions and subtractions in binary, I made a comment that there is really no subtractions or multiplications or divisions and stuff like that in most fundamental level. And so only the additions are performed. But then how do you actually do the add a number when you need to subtract? And so that's when the idea of one's complement, two's complements are used. So let me talk about them and then kind of tell you how and why they're used. So here's the concept of one's complement, and so the idea of one's complement is literally the opposite of what you got, right? So if a number is a 1-on-1, the one's complement is the exact flip of that. So it'll be instead of 1-on-1, it'll be 0-1-0. So which is pretty straightforward. And you may be asking, what's going on with that? Well, there's what's called a two's complement, and the two's complement is one's complement plus 1. So one's complement of this guy, let's say the number is 1-on-1, so one's complement we figured out to be 0-1-0. If you add 1 to that, 101 to 1, you become 011, right? So that's what's called a two's complement. And we use the two's complement to represent a negative number. So if you have a negative number, how do we represent that? Well, there is really no negative number. That's just a concept, right? And so we represent it by using a two's complement. Of course, you have to say we're using two's complement, because if you just look at that number, it just means 011, right? So we will have to say this is a negative number in some way, and we represent that actually by a leading zero, not this zero, but we'll put that into, let's say, like an 8-bit number, or 16 or 32, and the very leading bit will be a sign bit. So if let's say the very leading bit is a 0, it will assume to be a positive number. If the very leading bit is a 1, then we'll make it a negative number, right? So that's how we use the two's complement and one's complement, two's complement. But we do need to let people know that this is actually a negative number of this guy or something like that, right? So if we get to do a little bit of that, I'll come back and do some more examples, but that's what one's complement, two's complement is that's mentioned in your textbook. Okay, so anyway, let me take a pause here, and then I'll talk to you about the programming assignment. So let's talk about the programming lab. So this is similar to the payroll. It should be pretty straightforward, but let me bring up here. So basically, I'm asking you to write a grade calculator, and I give you an outline of what you need to do. So as an input, ask the user for name, ask for 4 exam grades, ask for 3 programming assignment grades, and the way that I like you to calculate is 4 exam grades are worth 100 points each, and altogether they are worth 60% of the overall grade. 3 programming assignments are worth only 10 points each, and altogether they are worth 40% of the overall grades. So the overall grade can be calculated using this formula here. And then I'd like you to print out what the user's name, the person entered, average exam score, average programming assignment grade, and then give it a grade. If it's the grade is above, these standard grades. And then try to format your output numbers to 2 decimal point. Okay, so let me show you how it looks like. So I'm using the online compiler, and I will post the code for you if you get stuck. There is no sense, banging your head on the wall, but try to do it without looking at it. But if you get really stuck, take a look at it, and if you still don't understand or missing something, then let me know and I'll try to help out. But anyway, I pasted the one sample there. By the way, there are multiple different ways of doing it, and I don't know if this one is actually altogether accurate. But as a demo, I will just run this guy here. So you should ask for the username, and then, as you can see, it's asking for the user name right here. So here's the input username. So I'm just going to say John or something. Doesn't really matter. And then it's going to ask for the first exam grade. And remember, they're worth 100 points. So I'm going to say 100, another 100, maybe a 90, right? And then maybe a 90, okay? And then it's going to ask me for the 3 programming assignments. The programming assignments are worth 10 points each. So you're going to put down like 10, 9, and 8. So once you do that, it outputs the name, average exam score, right? And then average programming assignment grade, and then overall grade. So that's how it prints out. Now notice that in the here I've asked for letter grade, right? So you will need to make that adjustments. I also want to point out, which you don't really need to do it at the moment because we haven't talked about it, but obviously when you run it again, and so A, B, C, enter the grade, you can put 1,000 or something, right? And then there's no error checking feature here, so you can say A, B, C here as well, right? And then it just crashes. So don't worry about that right now. We will talk about error checking and default value and stuff like that later. But just try to use a valid input according to this and make sure that it works out okay. All right. So hopefully that explains a little bit as to exactly what I'm asking, and then I think that's pretty much it. So let me bring in the lesson plan here, or let's look at the content here. So talked a little bit about this. I'll post up the lecture video afterwards. And then I talked about the questions here, the zyBooks, and then the calculator. In the assignment, in the lesson, this is something different. So in the lesson plan here, I may have given you some screenshots of how I did it in some other platforms. So you take a look at it if that helps you. And there's some other notes as well. Anyway, that's pretty much it. And so have a great week. Looking forward to receiving your work. So take care.